In this video, I'll be setting up the hydraulic prototypes for head walls. So I'll start by taking a look at a head wall prototype, and there's really not a lot of settings that go into these. One thing you'll want to pay attention to is the design structure elevation, setting that true or false, so probably going to be true for your proposed structures and then false for any existing ones. Has cross-section. This is only going to be used if you want to connect a channel to the head wall. Typically when you're using channels, they do not have their own cross-section information, so they'll need to be connected to cross-section nodes in order to get that information. But we can connect a channel to a head wall, so if you want to, then this would need to be set to true, and then from there we can pick either a regular channel or a trapezoidal channel to fill in the attributes there. In the prototype, I'm typically going to set this to false, and then this would be set to true if we are going to connect a channel inside of a project. The inlet description is used when analyzing culverts. So let's first take a look at a culvert prototype. If you recall this setting called isCulvert that's inside of a conduit prototype, when we have this set to true, we have two options. We can either set this to use conduit, and then we could pick an inlet description here for the head wall and the end wall. Or we can also set this to use start node and use stop node. And in this case, the conduit will automatically use the inlet description that we already selected inside of the adjacent head walls. And this will be used to model the head loss across the head wall for a given flow. And this is typically how I like to have this set up. And then we'll be creating a prototype for each different type of head wall we have. So not necessarily each size, but more so each type. So I'll have one for a CMP arch flared, for a CMP flared end, pipe end, and so forth. And then for each of these different types, we're going to have a different inlet description. Right. So to get to the manager for this, we can either click here, or if we go up into our catalogs, we can open up the inlet coefficients this way. So we can add in our own here, or this works like all of the other catalogs inside of Drainage and Utilities, so we can also import from a library, in which case we already have access to an FHWA culvert coefficients, which are going to be the HDS5 coefficients. A couple of resources for you. If you go to the help here, and then look up the inlet design coefficients, it puts it in an easier table, I think, to look at. So if you're trying to decide, what inlet description matches, which structure, this might be a better place to go first. And then of course you can always go to HDS5. Right, so I'll go ahead and import these first. And then I'll also create a prototype for each type of head wall. And then for each one of these, we're going to be setting an inlet description. Or if we go into the actual library, we can create our own. So I'm going to start here and basically create, I'm going to be reviewing each one of these, comparing it with what I can see in these other tables, and then coming up with the best selection for each type of head wall. One thing to pay attention to is the barrel shape. So some of these are named the same, but they'll be slightly different between an arch or a circle or an ellipse or so forth. So I do recommend renaming these so that it's more clear what they're for inside of this drop-down list. So let me start here. So I'll just go ahead and create a copy of this one here. So this will be like RCP or CMP arch safety ends or sloped ends. And if we want to push this to the top of the list, we'll want to put an underbar in front of it. And then that's going to push that to the top of our list here, make it easy to go in and select. So I'm going to do that for every type of head wall that I have here. And I'll go here and find my circular one. I'll duplicate that, and that'll be my RCP, CMP, circular safety ends or sloped ends. Maybe I need one for box culverts, and call this one box culvert sloped end. And again, I'm going to put that underbar to push it to the top of the list. I'll do just a couple more, so I'll go ahead and duplicate this one. This one's going to be RCP, CMP, arch, flared ends. And then one more, I'm going to do one for circular. So once you build your library here, you could even export these out to a brand new library and then clean it up to where you don't have your other entries, or you could leave them both in there. And then the designers would just get familiar with knowing that the ones with an underbar are the custom ones. So from here, what you'll do is you'll just go in and assign these. But once you go in and you set up all of your head wall coefficients, then you'll want to go over to your feature definitions and assign the prototypes to the feature definitions.